nice and crowded, I'm sure. All right, so this is slide number 10. And so solids, liquids, and gases are our main states, and then plasma is our fourth. We don't want to forget about it because it is important. It's actually the most common state in our entire universe because it's so common in space. Okay. So you have to have extreme high temperature and high energy, and it causes particles to become charged. We know that charged particles or atoms are called ions. Okay, so this is dealing with ionized atoms. Okay, so these electrons have been stripped off, making them, the atom itself will be positively charged, but then you have these negative electrons, and so you get this charged, high energy kind of gas. And I had said on Friday, it's not necessarily correct, but the way I kind of think about it, it's always like gas on steroids. All right, it's really energized. Stars are in the plasma state. And so if you think, if you look at those pictures where it has the sun and then all the planets, the sun is so huge, it dwarfs everything else. And that's just one star in our universe. So you think all the stars are made of plasma. You can compare that to how large the sun seems for our galaxy. Think of all the stars and they're all made of plasma. So it's kind of easy to see why plasma is so common. But here on Earth, we see this in lightning. Fluorescent tubes, plasma TVs were kind of a big rage, I don't know, probably 15, 20 years ago. The auroras borealis, which is their northern lights, and obviously our stars. Okay, so those are kind of common, and honestly, I don't really need you to know a whole lot more about that state of matter. I just don't want to skip it because it's there and it's important. It just doesn't quite follow the same kind of patterns and trends as our other three states of matter. Okay, so these are our examples for plasma, and so you can see these northern lights, the auroras borealis there. Has anybody ever seen or used a plasma cutter? What's it for? What do you use it for, Dane?
Cut metal.
Good, right? Is it like make a real jagged, like uneven cut, or how does it cut?
Uneven.
Okay, so is it kind of, it's almost like does it look like kind of like a beam coming out of it? Yeah. Right, and so basically it's just highly focused energy, and so obviously it's able to cut that metal, which it's hard to cut metal, right? Have the ones you've seen kind of look like this? Pretty similar?
Yeah, we have a giant table.
A big one? Okay. Nice. All right. If you've ever seen those little, I used to have one, my son had one, and I cannot find it. Which you think, how can you like lose it? It's like this big, it's like as big as a basketball. So I don't know like what happened to it. But if you've ever seen like when you plug these in or turn them on, like it's just like clear and there's nothing going on, and then when you plug them in, it has that current and it causes, it looks just like this. And so basically you're kind of making a temporary, they call them plasma balls. But just kind of, we can use the plasma state and we understand like it has uses here on Earth. But again, it's most prevalent out in space in our stars. Just some more pictures. Okay. All right, and so just a couple little explanations of how it's used. So with a plasma TV, they have all these teensy tiny little cells, and they have xenon and neon gases in them. And so when electric current passes through those cells, it gives off energy in each of those cells, and it causes the phosphorus that's inside each of the cells to kind of glow or light up. And those tiny lights combine together to kind of make the pixels that form the image that we see on the screen. Hey, I know it's warm in here, I know it's Monday, I know it's dreary. See up? Shaking. Whoa. Good morning. Wow, that was like hardcore sleeping. Woo! Hey, that was a quick doze off. All right, let's kind of check to see how you guys are understanding this, make sure we're good. It says matter can be classified as solid, liquid, or gas. Again, we're gonna kind of ignore plasma beyond what we just talked about. And so fixed means it keeps its shape. If it says indefinite, it means it's not fixed, that it takes the shape of the container. All right, so if we look at, let's look, I can't remember if it goes down. I think we go across first. So let's look at the solids. So does it have a fixed shape? Who thinks fixed? Okay, who thinks indefinite? Okay, you have to make one of those votes. 2 or 3 be voted, which I appreciate. That's it though. So who thinks that a solid will have a fixed shape? Who thinks it will have an indefinite?
Well, I'm ready to vote.
I know, they're getting warmed up. They're getting their brains warmed up.
Ready.
All right, volume. So how much space is that solid taking up? Is that gonna be fixed? Who thinks that's gonna be indefinite?
Oh, I'll go fixed.
All right, let's go back. Who thinks it's gonna be fixed where it's set? All right, who thinks it's gonna be indefinite? Okay, it's actually gonna be fixed because like if this is my solid, if I move it here, if I move it on the table, wherever I move it, it's gonna stay the same. And that's what fixed means. The amount of space that this is taking up, or my pen is taking up, or my mouse is taking up, that's not changing. All right, can we compress the space between the molecules? Can we get rid of the space between the molecules? So, can I take out any of the space between these?
No.
All right, who says no? Who says yes? All right,
Bro, it's on paper.
paper.
all right.
I meant yes.
Is a solid able to flow? Can I pick this up and pour it?
No.
No.
Good. All right, liquids. Is a liquid gonna have a fixed shape? Or is it gonna take the shape of its container?
The shape of its container.
Yeah.
All the way.
it says.
All the way?
Right.
Garrett is like awake and like ready for science this morning. Good. It is indefinite. Whatever the shape of the container is, that's the shape of the liquid. So, if I pour the water in here, now it takes this shape. If I pour it in here, now it takes this shape. If I pour it on the table, we're gonna kind of take this flat shape of the tabletop, right? How about for volume? Is it going to have a fixed, excuse me, a fixed volume? Who thinks it's gonna be an indefinite? Okay, this one is a little bit tricky, and here's why. It's actually fixed because if I have 200 milliliters of water, it's gonna stay 200 milliliters of water no matter if I put it in a giant beaker, if I put it in my little container, if I pour it in here. The shape of it's changing, but the amount of space that it's taking up is actually not changing. And that actually tends to be probably the trickiest one because you're like, oh, it doesn't have its own shape, which is true. But it does have its own amount of space. Like it's gonna take up the same volume no matter where it is. Unless you remove some of that liquid, then obviously you're changing the volume. But if you're keeping the same amount, then the volume stays the same no matter what it's in. So it's actually considered fixed. Can you compress it? Can you take out the space between the molecules? Is there enough space to do that?
No.
Okay, so we're gonna go, anybody wanna go yes? Couple? Actually, no. So even though there is a little bit more space between the molecules, we don't have a way to compress it and force those molecules to come closer together. Is a liquid able to flow? Who likes no? Who likes yes? Okay. A gas. What about the shape of a gas? Is it fixed? Is it indefinite?
Got it's on
Good.
paper.
Hey, you know what? Sometimes
raising their hand.
people don't even notice. So
I'm not.
kudos to you to notice.
I'm making sure.
All right, volume. So is the amount of volume that something is taking up, like the space it's taking up, gonna be fixed for a gas?
No.
Or is it going to be indefinite?
Indefinite.
All right, because it's just gonna take up the, like, it's contained. If you block it off, if you put a lid on it, it's gonna stay put, but it's just gonna fill up the whole area that it has access to. A liquid, like, if I put a liquid in here, we know it's not gonna just randomly levitate and fill the whole thing, right? So again, think about what you know. Oh, man. I guess it's already on the paper. Can you compress a gas? Okay, and we watched those videos on Friday that kind of showed that process where it's definitely different than other states of matter that are uncompressible. Is a gas able to flow? And again, we haven't watched this example in, there's a great one in the Bill Nye that we'll watch. Are you able to have a gas flow? What do you think?
Yeah.
It is, and again, once we see this example, it'll probably stick with you, but definitely able to flow. Not bad. All right, and so again, here's just some pictures. If you had these three pictures, I'm expecting that you should be able to identify that these are showing a solid, a liquid, a gas, solid, liquid, gas, and again, solid, liquid, gas. So all of those, like, you should be able to kind of at this point, if you couldn't already, recognize those states just from the pictures. Okay, let me back up. Oh, I think this is gonna, it always jams up right here. Let's go to, I have these couple videos. No, I told you, it was a pretty easy day, lots of video day.